Good afternoon, everyone, and welcome to MetalCon Live. I'm Judy Geller, Director of MetalCon, and I'm here with Kaylin Burke. We are very glad you could join us today for the MCA Presents The Advantages of an IMP Roof. Greg Lusty and Brian Ng from All Weather Insulated Panels are our guest presenters today. As you can see from the slide currently on the screen, there are many benefits to becoming an MCA member. For more information, please contact Jeff Irwin at jeff.irwin5135@gmail.com. You may be aware that last week we kicked off our Metal Focused Safety Certificate program. This series has really resonated with the metal construction community. If you missed it, you can access it at the metalcon.com website under the MetalCon Live tab. The series continues tomorrow with fall protection planning. It's live at 4 o'clock Eastern Standard Time. And with this series, you can take one or all of the 10 course program, as many as you wish. On March 10th, our MetalCon Business Academy series will continue with a really important topic called Attracting and Hiring Rockstar Staff. Danny Kerr, who's one of our MetalCon favorite presenters, will be leading that session. And also, we don't want to forget that after a year of disruption and pivoting, emailing and Zooming, we're looking forward to getting together safely in person at MetalCon in Tampa next October. We have added several new exhibit pavilions. We've got fresh education, networking, inspiration, and fun. And we really hope you'll be able to join us. Finally, if you need technical support, reach out to MetalCon support in the chat box. And don't forget to complete the webinar survey so you can get your credits. That's it for announcements. I'm going to hand it off to you, Greg.
Great. Thank you so much. Really appreciate you having us on today. And we're excited to share what we know about insulated metal panel roofing. So Brian, I'll just ask you to go ahead and share your presentation there. So again, thanks for having us. I appreciate everyone joining us today. I know things are busy in the marketplace, so we're all excited about where things are headed and from that standpoint. And today we're going to talk about insulated metal panel roofing, something near and dear to my heart, and something that I believe we will continue to look to grow this as a type of product in the roofing space. You can go ahead to the next slide. One of the things, just before we kind of get into the IMP portion of this, from an MCA standpoint, just want to remind everyone what a great resource the MCA is with regards to, if you have any needs from a metal standpoint, insulated metal panels specifically, or other metals, our focus with the MCA is really to help promote metal as a product for use in construction, to focus our attention on the architectural community and assist in any way, shape, or form that we can in the design and performance of building systems, and to also educate our members or our prospective clients on the use of metal in construction, and that's what we intend to do. So again, please visit the MCA website for more information on anything metal. Go ahead, Brian. So the IMP Alliance is a subset of the MCA, and our charge is really just focused on IMP specifically. And the group is made up of several manufacturers in the space, as well as many of the suppliers in both the steel and the chemical side of the business. In my opinion, we have provided the marketplace with some really valuable resources. We go to bat for policies, and all with the aim of really taking insulated metal panels and providing the marketplace with information so that the product can be usable for construction. So with that said, we'll move on to the next slide, Brian. Today we really want to focus on the education part, obviously, of our charge as an alliance. And so with this presentation today, we're going to be focused on 4 major objectives. I'll go ahead and take the IMP Roofing Overview, talk a little bit about features and benefits, And Brian and I are going to kind of hand this thing off back and forth, and he'll touch on some of the structural attributes of insulated metal panels, and also get into some of the applications and installation methods of the product themselves. So with regards to IMP and an overview, insulated metal panels, you can go ahead to the next slide, but insulated metal panels have been around for some time, the 50s and 60s. We'll talk a little bit about the roots, but when you think about insulated metal panels, really what it is, it's a sandwich panel. So it's a one component system that provides an air, water, thermal, and vapor barrier for a building. So it's a sandwich panel, very lightweight. A 3-inch panel might be somewhere in the neighborhood of 3 pounds per square foot. So it's comprised of 2 metal skins, most typically a galvanized steel skin, and an insulating core. And that insulating core could vary depending upon the thermal requirements of the project or where you are located in the world. But simply put, usually between 2 inches and 8 inches thick. And again, the selection of the product would vary. It would be dependent upon where you are and what the thermal requirements are for the building. We'll talk a lot more about colors, profiles, options, availability of the product, but that really is one of the main strengths of insulated metal panels, is that you get such phenomenal performance and efficiency and simplicity out of a single component. And so we'll talk quite a bit about that as we move through. And then the other side of it is the testing and the certification of the system. The manufacturers of insulated metal panels have been in the industry for some time now and have fully tested these systems in both structural, thermal, fire. They're fully tested, fully certified, and you can believe that they're appropriate for almost any building application at this point. So very flexible product. So I mean, when you look at where IMPs are today, it's no longer a new product in the marketplace. We talk about insulated metal panels being an innovative product, and they are, but they're by no means new, right? We're now talking about over 50 years of existence in the United States. And this picture here that you see is really one of, if not the first, insulated metal panel production line in the United States. And this was developed back in the 60s in Richardson, Texas. And I think on the next slide, you'll see a photo of the interior of that building. And actually, I believe that this particular facility in Texas, at least the guts of it, is actually one of the IMP Alliance's members' plants today. So this is still kind of live today in Texas. So a lot has changed since 1968. I think this is where that kind of innovation comes into play, and you think about where we were versus where we are with how we make insulated metal panels and how we've been able to achieve such leaps of performance and efficiencies over the years. So just to give you kind of a quick history about how things were made then versus how they are now. Still back in the 60s, we were looking at roll forming equipment to form pans, and we were looking at foaming technologies to insert foam into the 2 sheets of steel that make up the sandwich panel. So on the left side of the screen, you'll see a pan being roll formed, and then on the right side of the screen, you'll actually see, at that time, those pans would be kind of seamed together or bonded together with a piece of equipment and then foamed. Today, we've done a lot to improve both the efficiency and the effectiveness of that equipment. Now we're roll forming much wider panels, not having to put smaller pans together to create a full roof system. And I'll show you that here in a minute. But this is actually a photo of what or how we used to foam these panel systems. So you basically would have what you see there, a big box that they would put the two skins of steel in, and they would insert the foam chemicals, and they would, basically bond those together through heat and pressure, chain those down and squeeze the panels together for a certain amount of time, and it would come out a single panel. That panel would be lifted up and out, and the next one would be inserted into the what I call a coffin system, or some kind of a laminator system. I was not in the IMP industry in the 60s, but have learned a lot about it over the years. So that's kind of where we came from. Fast forward now to where we are today, and you'll notice things are quite a bit different. Back in the 60s and 70s, most of this equipment was controlled by hand. Today, all of the equipment is controlled by electronics, right? So we have computer-aided software that is really just controlling all of the elements of what it takes to make a panel, whether that's line speeds, all of the chemical flow that needs to happen to deliver the appropriate quality to the line, temperatures, and all those things. Those are all controlled now by systems. We also have continuous manufacturing lines, rather than having to put one panel in at a time, take one panel out at a time. We're now able to manufacture these products in a continuous method, and we'll actually show you a very quick video of what I mean by that. But so what that does is, it really helps with efficiencies, and we can put out a lot more square footage in a day than we used to be able to do. But this video will show you what I mean by that. So here you're looking at an actual production line for insulated metal panels. This is a roof product being produced, and you'll see this is protective film being applied to the exterior face. Now what you're seeing here is an actual roll forming station where we're putting the actual panel profiles on the metal itself right in line, and that's what we mean by continuous. Here is a shot of a foaming station, and side guides and the laminar. Actually, this is the metal going into the laminator. Now it's coming back out the other side with foam in place, and that's probably a 6-inch panel that you're looking at there. So a 6-inch thick panel coming out the other end. Again, all nonstop, right? So this is all in line, all being done continuously. That line is not stopping, even when it comes down to cutting the panels. We don't stop the line to cut the panels. So the panels are cut in line as the panels are coming off, and you can see that saw is actually moving down the line with the panel, so we don't have to stop the line. So again, a lot of efficiency built into these lines these days when you compare to where we came from. Here you're seeing the panels being sent down the line. This is at the end of the line, and they're actually being picked up, and they're set into a cooling rack so that the panels can cure before shipment. So from here, the panels are basically cooled, wrapped, stacked, and they're shipped right out to the job site. So most typically panels are made to order. And so we're building based on the architectural specifications, whether that's thickness, length, color, gauge, you name it. Manufacturers can take these systems and build them to suit. So that's how a panel is made. We'll take questions here at the end of the session, at the end of the section. So if you do have any questions, I'd be happy to answer those here. Whether that's about the process itself or product itself. So we'll address those in a minute. From an IMP roofing standpoint, so there are some options out there from a roofing standpoint, and the options that are available in the industry really are based on the traditional metal roofing options that exist even today. But single skin metal roofs have been used for years and years and years in the construction marketplace. And now, again, through the innovation of IMP, we have made basically those types of profiles available in a single component system that provide the air, water, thermal, and vapor barrier in one component. So those options really come down to whether you have a standing seam profile, and within standing seam, we'll look at those individually. But there are a few different types of profiles available in the marketplace, and those are actually concealed, fastened to the substrate or the structure, and then seamed mechanically on site, so that now you have a rigid roof system. We also have through fasten profiles available in the marketplace, several different profiles depending upon the manufacturer of your choice. Again, very efficient, very effective. The main difference between the two is that one is mechanically seamed, the other one is through fastened, and meaning that you're going to see the exposed fastener. So you can go ahead, Brian, and we'll kind of take a closer look at the profiles available. So again, I mentioned that the joinery systems for standing seam roofing, has really been based upon what is known and loved, frankly, in the marketplace from a metal roofing standpoint. So for those contractors on the call, or for those architects on the call that might be used to designing or installing metal roofing systems, this should look very, very familiar. Other than the fact that now you have foam within the panel system and a liner side metal skin. So again, I had noted this is a concealed fasten system. So this is really the most traditional of all the insulated metal panel roof systems, where you have a traditional standing seam leg. The two panel systems. So this is your joinery in the middle here, and where that arrow is pointing is basically your standing seam leg. That's a 2-inch high standing seam leg. One side of one panel is connected to the other panel by this seam, and then again in the field that seam is mechanically fastened. Within the joinery of the panel system itself, you might notice there is a clip in here, and that clip and fastener combined is what actually allows you to fasten that first panel to the substrate. Then the second panel on the right is installed over top and then seamed. So when it's all said and done, the beauty of it is it looks like a traditional roof, and now you have a much more efficient and effective system. We believe, when you use an IMP over traditional methods, in that now your one pass on the roof is installing the air, water, thermal, and vapor barrier for the building. Not to mention the fact that you have all the flexibility in the world with gauge, color. These systems are typically available in 36 to 42 inch wide systems. Traditional metal systems are typically 12 to 18 inches. So you're getting a lot of bang for your buck from an installation labor standpoint as well. Okay. So another option for standing seam roofing, the T joinery. This is a very, very similar joint, obviously, when you're looking at it on the profile stand side of things, but the main difference being that you now have a system where, rather than having the joint being mechanically seamed on one side, you now have a joint that is shaped like a T when you butt the two panels together and in the installation, and then you're actually taking that mechanical seamer and you're running it above the top with a cap there, as you can see where that arrow is pointing. So again, mechanically seamed in place, concealed fastener, like just as you saw on the earlier slide. Really no difference from an installation standpoint. The difference being that in this case, this panel joiner is slightly different, and you might have the opportunity to actually remove this panel in the field. If one was damaged, you could take that cap off and remove the product. Again, not real easy to distinguish really between the two systems, or distinguish between if this is a traditional metal roofing system or an IMP once the product is put in place. And again, I believe that's the beauty of it, is that it's a really good looking roof once it's all said and done. Not to mention the efficiency of it. And then the final main option in the marketplace from a standing seam roof system available in the marketplace today is what we call a trapezoidal joint. And so if you look at the similarity between this and the traditional joint, this is very similar to what you saw in the first representation. The main difference being that there is an option in the marketplace for a trapezoidal joint, rather than that panel coming all the way horizontally to the upstanding leg. There's a 1-inch trapezoidal shape moving into the joint. Why? One, aesthetics, and two, it's believed that this could prevent some opportunity to bend that upstanding leg if you were to stand on it, or if there's a lot of foot traffic on the building. So mainly designed around those two purposes. Again, mechanically seamed in the field, concealed fastener. Slight difference when you look at, this, I guess from a 50,000 foot view. When you look at the installed pictures, you can go to the next slide there. Yes, so you could just notice a slightly different look, a little bit of a bolder rib there than maybe in the other systems that are out there. Again, preference, choice of the architect, choice of the owner. Maybe scale of the building might have something to do with choosing one over the other, but they are available. So that was the standing seam option. Again, I had noted that there were two main options: standing seam and through fastened. You're looking now at a through fastened system. The through fastened systems in the marketplace today, again, are typically somewhere in the neighborhood of a 36-inch wide or a module of a panel to up to a 42-inch module or 42-inch wide panel. One of the other things I hadn't mentioned yet is that length comes into play quite a bit with these. These can be made very long. So if depending upon your roof, you might be able to design a single panel to cover the entire run of your roof, or you can stagger joinery, and that can be accomplished for longer runs as well. Brian is going to get into discussions about span and structural capacities here in a moment, but that's another huge benefit for these systems, is that you're gaining so much efficiency in the performance and the installation, but you're also gaining efficiencies on the structural capacity side of things as well. This is another example of a through fasten system here. This is an overlap leg. You can see here the main difference between this system versus the standing seam roof system is that you are going to see a fastener every so often, usually at the girts, for these types of systems. But again, very efficient, very effective systems. Typically a bit easier to put down, a bit faster to put down. So if you have the economics when they come into play, this might be the right choice for that type of a project. And again, when you look at the installed pictures, you're going to notice that, again, color comes into play. The finish capabilities of utilizing metal in any one of these installations can take even an exposed fasten panel and make it look highly architectural. That's the beauty of metal. That's the beauty of having some of these choices, is that you can utilize either one of these systems and get a truly efficient and effective system in place at your budget. So I'll pause here. That was probably a bit of a mouthful. If there's any questions, I'd be more than happy to entertain them. I think we do have some. What are typical line speeds? Yeah, so that's going to vary depending upon thickness of panel, depending upon what you're trying to achieve. But Brian, what's our average? Do you know what our average line speed at our plants are?
Yeah, I think it's going to depend on the thickness. It can range from 5 foot a minute, or yeah, 5. Well, let's see. I'm trying to get the conversions done here, but yeah, 5 to 10 meters a minute, I would say.
Yeah. Okay. And then what's the typical span from purlin to purlin, South Florida hurricane testing? Yeah, Brian is going to cover spans, so we'll definitely touch on that. And there are hurricane testing approvals available in the marketplace for roofing systems like this. So yes, absolutely. And then let's see, do we have anything else? Are skins pre-sheared or post-sheared? So skins are coil fed for both the face and liner, or the exterior and interior sides of the panel. And they would be cut in line to typically cut in line to size. So if you ordered, if you had a requirement for a 30-foot long panel, we would cut them in line there, as you saw in that video right at the end of the line. You would cut that in line at the appropriate length. They can be cut in the field, and they're cut in the field very, very regularly. They're cut for a lot of reasons. Sometimes the panels are run long and cut short in the field just for flexibility of fabrication. We regularly have to cut panels in the field, for fabrication areas around windows, around doors, corners, eaves, you name it. The shearing is done at the end of the line, on almost on any line that I've ever seen, unless it's not a continuous line. If you have a line that's discontinuous, you may cut the skins, place the skins, foam it, take that panel out, right? But the lines that are being installed now today are most typically continuous lines. So those cuts would be done at the end of the line. Construction detailing, that's probably a different presentation, Rob. The question was, are you going to get into construction detailing, valley and eave terminations and such? But yes, we absolutely could entertain a conversation with you individually on that. Today's presentation is not going to get too deep into that, I don't believe. We may have a few details in here, but we could address that separately. Okay. I think we addressed line speeds, purlin to purlin, so we're good to go. I think so. Any other questions? Just go ahead and utilize the chat function, and we'll get them answered for you. But I think we're good to go here. So features and benefits. I've already mentioned some of these features and benefits, so we can go on to the next slide, Brian. But just speaking in terms of IMP and really what they're built for. I mean, the first thing that comes to mind is, in my mind anyway, is thermal efficiency, and it's all about thermal when you're talking about insulated metal panels. And in that, when that conversation comes up, you can be sure that IMPs really are the greatest, pound for pound performer on the marketplace when it comes to thermal values per inch. It depends on the manufacturer, but anywhere from R7 to R8 per inch. The higher the number, the better when you're talking about R value. The lower the number, the better when you're talking about U factor, right? So it just depends on what specification you're reading and what you need out of the panel. But again, the beauty of IMPs is that nothing changes with the actual production and the efficiency and what you know about IMPs, depending upon the thermal requirements. I mean, other than thickness, that's really all that needs to change. So very, very flexible in that, from that standpoint. So, thinking about an R8 per inch panel at 8 inches thick, you're talking about an R64. So I don't know of a code in the country that requires more than that. So, it's safe to say, I think you can use IMPs in just about any climate. I know, we've even shipped panels to Antarctica. So it doesn't get much colder than Antarctica. So next slide. So this chart just gives you an idea of, the R value per inch, and we'll use 7 for a good round number for insulated metal panels, typically utilizing polyurethane based foams. And you compare that to pretty much any other insulation material that you can find in the marketplace, and you can see that the efficiency per inch is just tremendous when it comes to insulated metal panels. Think about what you have traditionally had to do with insulation, especially in low slope roof applications where you have to utilize, typically a polystyrene type material, stack that insulation, stagger that insulation to get your effective R value for the roof. And you compare that to what you can do with an insulated panel, one component on the roof, and you're done. So it's really, really great when you think about, the minimization of materials, the simplification of the design process, the simplification of the procurement process, and the simplification of the installation process. There's a lot of value to be had when you talk about all of those things and what it does to really minimize, at the end of the day, to minimize risk for the client and for the building, whether that's risk in air and water infiltration, risk in thermal failure, risk in structural failure, risk of reducing installation errors, because now you're really just minimizing all of that risk by utilizing one component rather than so many others. So that to me is the real true benefit of IMPs, from the performance standpoint and from the minimization and of risk standpoint. So, further with the thermal side of the features and benefits, really one of the main things we talk about when we talk about insulated metal panels are that we, virtually eliminate thermal bridging with IMPs. And I'll show you here in a second what I mean by that, but you really do get a consistent, continuous thermal barrier when you're utilizing IMPs versus traditional types of construction. And it really does integrate easily. And I know there was already a question about construction details. And again, when you look at the construction details of IMPs and how they integrate with other materials, there's a lot available out there in the marketplace on how to utilize IMPs, not only on roofs, but walls, and how they can so easily integrate with other systems, whether that's windows, transition details. We're all seeing a lot more buildings utilizing different materials these days. And so, IMPs are absolutely a great choice when those instances come up. So again, further on continuous insulation, I mean, this is just one of those topics that came up. I don't know, I guess it's been maybe 5-10 years now that we've been talking about continuous insulation, and really IMPs just match up so beautifully when this topic comes up. And what is continuous insulation? I guess from a definition standpoint, I'm sure most of us on the call have heard of this, but as defined by ASHRAE, it is insulation that's continuous across all structural members without thermal bridging, other than fasteners and service openings. So, if you remember the detail that I showed you earlier, that fastener that penetrates through the IMP is not considered breaking the continuous barrier, right? Continuous insulation barrier. Okay, so this is a really good kind of representation of what we mean by continuous insulation. And on the left is a more traditional system where you would have your structural member, you would have batt insulation laid within the structural members or over the structural members, and then you would have had a more traditional single skin metal, whether that's roofing or siding. In this case, we're talking about roofing. Versus on the right, what you see there is an insulated metal panel with a metal liner side up against the structural member and a metal face, and then we would have either an exposed fastener or a concealed fastener if this were a standing seam roof, mechanically fastened on the exterior. Again, if you just look at the two, I think you can come to terms with the fact that you have much more efficient and effective insulation when you're outboard of that stud cavity completely, and you're not minimizing the thickness of your insulation at any structural member. So you're getting a full 6 inches at continuously along the outside of the building, versus every time there's a structural member here, you're minimizing your insulation thickness down to 1/2 inch or 2 inches thick, depending upon the system. So by nature, you're introducing much more risk of condensation, reduction in thermal performance in those areas. So we talked a lot about thermal performance and simplified design and simplified construction speed. One of the things we haven't talked about yet is sustainability. Another hugely important and increasingly important topic when you're talking about construction. And we all know the impacts that construction has on the environment today, and how, at least in the past, how inefficient some of our buildings have been as it relates to performance in the environment. IMPs really do lend themselves to sustainable design, sustainable construction in many different ways, as you can read here on the screen. I talked about a bit of that earlier when I talk about minimization and I talk about simplification. I mean, to me, that's at the heart of sustainability. Anytime you can minimize, the number of materials you're bringing to the job site, you're minimizing scrap. You're minimizing the number of trucks that are being shipped to site. You're simplifying the design. You're simplifying the delivery. You're simplifying the installation. That lends itself, in my mind, directly to sustainability. Beyond what you're seeing on the screen here, obviously, steel itself is hugely important from a sustainability standpoint. In that, we can use quite a bit of recycled content, and just about all of the steel used can be recycled at the end of the service life. Also touching on the VOCs side of things, there is no measurable volatile organic compounds utilized in the system, so that's a positive when you're looking at LEED certification and those types of things. There's been work done now about ozone depleting potential, the global warming potential, and those types of things have been published and can be found on the MCA, relative to the IMP's performance in those areas, and also we're contributing significantly towards net zero energy buildings, and the easiest part of that is just the effectiveness by which these things perform in place, right? Not to mention that you can now, look at integrating photovoltaics and those types of things into roof and wall systems as well. I mentioned earlier a bit about the flexibility of insulated metal panels and paint systems is one of those areas where, no matter what color you want to put on your building, you pretty much can do it with IMPs. The most, I guess, when you think about roofing, and I know not a lot of us have been flying lately. I have been flying a bit, but when you look out of a plane window and you see the miles and miles of roofing out there, it's typically white or light, right? And that's for good reason. So, when we talk about paints, yes, we have so many options available, but for roofing systems, typically it's the cool colors that you're used to. That's how you're going to get the efficiencies out of your buildings, using the cool colors. And the Cool Roof Rating Council has done a great job specifying colors that will lend themselves to cool roofs. And so we do pay a lot of attention to that. Any manufacturer's literature that you see is going to include CRRC roof pigments. So just definitely want to keep an eye out for that. So I'm going to pause here before I turn it over to Brian again, and I think we might have a couple of additional questions. Does the joint of the IMP perform thermally, i.e. the same U factor as the joint as in the middle of the panel? There are tests that will give you the answer to that. There's a couple of different tests that we test panel systems to in the marketplace. ASTM E518 will give you a performance of the panel itself, and then ASTM C1363 will provide you with the performance of the system, including joinery. So if you want to just remember those two tests, and you can peruse the technical information from the various manufacturers, but those are the two that will give you that answer. Do you have some experience with Rockwool as an insulation? Yes, good question. There are wall systems available with Rockwool insulation, most typically used for fire applications. So fire ratings on wall systems, Rockwool provides a really good opportunity to gain fire ratings with an insulated metal panel. So it'd be the same thing: steel, Rockwool insulation, steel. 1, 2, or 3 hour wall systems are typically available. I don't know of a roof system, Brian, that is available with Rockwool at this point. I know we particularly don't have one.
Right, I don't know of one at this point as well.
How is insulation removed from the panel before or during recycling? Good question. I have had experience with some of that. Where one of the interesting things about IMPs is, being that they've been in the market for about 50 years now, or a little more than that, is that the majority of those systems are still in place. So we don't have a lot of recycling going on of panel systems themselves. But when that does occur, there are ways to remove the foam. Basically, you just grind it off. You strip one side of the metal off, grind the foam off, and recycle the steel. And that can be done for just about any product. Okay. I think we've got those questions answered. And in the interest of time, I'll go ahead and Brian, hopefully I didn't take too much of your time, but I'll turn it over to you.
All right. So yeah, so Greg mentioned, some of the features and benefits, but I will say, one of the other key benefits is the structural attributes of insulated panels, insulated roofs. It does have a really high strength to weight ratio. So the weight of the product, with the steel facings and the foam, generally will weigh about 2.5 to 3 pounds per square foot, depending on the gauge and the width of the overall panels. But because it is a composite panel, the insulated panels, will perform really well against transverse loading, which is the load that's going perpendicular or applied against the front face or top face of the panels. So these are typically your wind uplift loads, any gravity loads, dead loads, snow loads. And because of the composite nature, the insulated roofs is going to act like an I-beam, where each, component, the steel facings and the foam, is going to resist certain types of stresses, within that product. So steel facings, it acts like a flange on an I-beam. So it carries all the bending, tension, and compression loads, and then the foam core itself, on completely flat profiles, the foam core itself would take the shear loads, which is similar to the web of an I-beam. On profiled roofs, trapezoidal roofs, ribs at the standing seam, that's going to contribute to the shear capacity of the panels. So it's going to be a combination of the foam and the profile of the steel for those types of panels. So two standard methods are used to determine the panel's bending, buckling strength, and the shear strength, and it's typically ASTM E72 and ASTM E330. With these tested results, the capacities of the steel facings and the foam core is determined, and then in turn that can be used to determine maximum spans for any project-specific conditions. So due to the high strength to weight ratio of panels, there's excellent spanning capabilities between supports. What this does is it allows designers to optimize the roof design and space the purlins as far apart as possible, get for any given project, and to reduce any steel requirement on the roof. Here's an example of a load table. So each manufacturer is going to have their own load table specific to the profiles, specific to the connection strengths and the supporting steel. So I think it's important to read the notes of each of the load tables, because the information can be presented a little bit differently, but the main governing factors to determine what the maximum spans are, would be the buckling strength of the panels, the core shear strength of the panels, the connection strength of the clip and the joint itself, and the pull-out values from the fasteners from the structural supports, and then depending on the project requirements, there's deflection limits that would come into play as well. But generally, each manufacturer will have their own load tables, but if there's a specific scenario that doesn't capture the project-specific requirements, and any panel manufacturer will be able to run those calculations for your design. So we'll do a quick stop for questions here. Let me see if any's come through.
Yeah, I do see a couple, Brian. One, does polyurethane lose R value over the years? you know, and I would say this, it does if unfaced. You know, one of the benefits of IMPs is that, you know, with the fact, due to the fact that the polyurethane or polyisocyanurate, as we call it, the core is encapsulated in foam skins. We have less aging over the years when compared to other installation systems. Are there particular challenges with rock wool regarding adhesion? Yeah, I mean, when you look at rock wool versus foam insulated metal panels, there is a difference in the way that the foam is adhered to the metal skins. In the foam, it's a in a foam insulated metal panel, it's a chemical reaction, and in a rock wool insulated metal panel, it's actually glued. From a challenge standpoint, you will get different spans for rock wool versus foam because rock wool is heavier, foam is lighter. So, you know, the challenge really becomes more about how do you utilize those panel systems within the design of the building to get the spans that you need. Again, usually we would promote foam insulation, foam insulated metal panel systems as the ultimate solution for use in construction when you're looking to be thermal efficient. We would think more about rock wool systems when you're thinking about utilizing IMP when there's a fire rating need. So that's kind of the balancing act, so to speak, between the two systems. How do we read the table where is shown the span and thickness? Brian, I'll leave that one up to you. Do we have that available that we can review?
Yeah, we can, let's see here, and go back to this one. Yeah, we can take, again, as I mentioned earlier, each manufacturer has their load tables presented in a different manner. So it looks like for this particular one, you know, the top portion, it's the design criteria between the panel itself and the deflection limit. So it looks like that's the panel strength based on the panel thickness, and you can see the maximum loads for each of the spans for those conditions. And then there's also a separate table for the connection strength. Similarly, you know, looking for the maximum load for that particular connection strength, and usually you would just take a look at the lowest value for each given span, and that would be your maximum based on the governing criteria.
Good. So a couple more, Brian, before we move into applications, and I know we're getting a little short on time, so I'll keep this short, but are diaphragm capacities available? Traditionally speaking, with a sloped insulated metal panel roof system like we just talked about today, the standing seam roof or the exposed fastener roof systems, no, diaphragm capacities won't typically be available. I will say this though, if you have, because there are innovations now that have come out in the last 12 to 18 months or so with the insulated metal panels, where we're utilizing a similar, but not the systems we talked about today. We're utilizing an insulated metal panel in low slope roof applications where you would eliminate traditional deck, vapor barriers, insulation, cover boards, and a membrane, and replace it with an IMP and then put a membrane over it. So we didn't cover that today. That's a whole nother topic, and one that we'd be more than happy to talk with you about. I would say get a hold of Brian or myself. We'd be more than happy to talk about that system because it is sort of a revolutionary system that's being introduced in the market today. The span tables that you see that we just shared, Dennis, this was a question, are the span tables based on flat applications or sloped applications? I'd say, again, traditionally those span tables would be relative to sloped applications like 1/2 and 12. The insulated roof deck applications would be more like a 1/4 12 or less. Okay, anything else to, I think we covered the rest. Insulation aging, we covered that. Yeah, we're good to go. Okay, Brian?
All right. Yep. All right, well, so we'll go over several different types of applications now. So IMP roofs, they install a lot more quickly than single skin systems. So as Greg mentioned earlier, the exterior facing, interior liner, and insulation, it's all one composite. So there's only one unit to install and everything's all done in a single step. It's not going to require multiple layers to be installed, which then, in turn, it reduces the amount of time that's required to dry in a building. And this is important because it's going to allow other trades to start working on the inside of the building, and it's going to increase or decrease the timeline for the overall project. Also, because panels install quicker, it also reduces the amount of time that's spent on a roof, which would increase the job site safety aspects. The rigidity of the insulated roofs, it's a really strong product. It's going to be able to provide a stable working platform for installers to work on. And also, because of the high R value and impermeable facings on the panels, it is going to be an ideal application for cold storage and controlled environment applications. Another application is retrofit. After a certain amount of time, older roof systems will need to be replaced. Insulated panels, they're an excellent option for that. Here's a photo here showing a single skin roof with fiberglass insulation being removed as insulated metal panels are being installed. And we actually have a video of this, time-lapse video of this. Let me show that here. So you can see the original roof being removed, and at the same time there's a crane crane with suction lifters setting down the panels as the original roof is being removed. So that'll give a good idea there. I'll move on to the next slide here and kind of go through the installation. I mentioned earlier, during that video, there's the suction lift, there's this crane. Generally, panels will weigh about 2 pounds to 5 pounds, and it's going to depend on the gauge. 26 gauge on both sides, it's going to be a lot lighter than having 22 gauge facings on both sides. So, the panel weight should be taken into consideration during installation. Shorter panels, they can be lifted with moved around the roof with 2 people. Also, to move the panels onto the roof, there's equipment such as suction lifters. They're attached to a crane or a boom, and the suction lifters essentially act as a vacuum, and they suck up the panel facings, and it can lift the entire piece of panel onto the roof. The amount of suction cups that are needed would depend on the profile. There's different shapes that will fit certain profiles, and the spacing of the suction cups would depend on the length of the panels as well. But it is one of the most efficient and safest method to move panels onto the roof. Here's another method of moving moving panels onto the roof. The entire bundle is carried up with the crane, and the entire bundle will be moved on the roof. That way, it can be be manually carried off the bundle and installed into place. So part of the installation is NLAP and EVE preparation. I would say this is unique to insulated metal panels, where the what we call a cutback is made on the bottom side of a panel, and that portion of the panel will need to be removed. So the interior face is cut 3 to 6 inches depending on the application. The foam is then, the steel facing on the bottom side is removed, and then the foam is removed as well. What this allows is, panels can be made in lengths from 8 feet up to about 70 feet, depending on the panel thickness. But with larger roofs, we are going to have end-life applications where the upper course roof would have to kind of have a shingle effect and overlap the lower course roof. And in order to do that for insulated panels, we have to remove the foam, leave the top facing intact so that it can overlap the bottom. And we have a video here showing how the end laps can be removed. This is a standing seam panel. The seam is cut off, and then a metal scraper is used to scrape to cut the side tape, cut the foam. Usually, a bread knife can be used to cut off most of the foam. Grinders can be used to clean everything off. What we want to make sure is that there's no foam that's still on the bottom surface of the exterior facing. We want to make sure that there's a nice clean surface there. So overlaps the next panel. There's no air cavities or gaps or anything in between there to allow water or air to penetrate. So this can be done on the ground, and to optimize each panel bundles, usually for roof panels, because there are the standing seams and the trapezoidal ribs. Each panel is flipped so that it maximizes the space on a bundle. So at the job site, panel lifters can be used to flip panels and make sure it's in the correct, it's facing up so that it's easier to remove. So here's a photo showing how it can be done on sawhorses. And that's it for the installation portion. Do we have any questions on that?
I do not see any questions in chat. So I'll go ahead and wrap things up. We've got a few minutes left, and again, really appreciate everybody's time, and your questions have been great. So thanks for all the questions. Yeah, I mean, in summary, we talked about quite a bit relative to IMP, but I think at the end of the day, from an IMP standpoint, the key things to remember are that these systems have been around for a long time now, for 50, 60 years in this country, and can be used in many applications, whether you're talking about a commercial or industrial type application, warehousing, storage, cold storage. The picture behind me is an entertainment facility. So if you're designing facilities like that, or an architectural type facility, educational facility, you name it, IMPs are a really great option for a lot of the reasons we just talked about. They're an efficient, effective performer when it comes to air, water, thermal, vapor barrier. We talked about all of the great things that the simplicity of the design of the product, and how it lends itself to simplicity and design of your buildings. Just think about all of those details that you can just throw away and pick up one detail and be done with it, whether that's a roof or wall application with a single component solution like an IMP. Not only is it efficient in design, but it's also efficient in the procurement process. You're limiting the number of contracts that you're introducing into the construction cycle. Therefore, you're limiting risk on the installation side of things too, because you're eliminating so many different passes, whether that's a roof or and wall system as well. So, and Brian talked a lot about the technical aspects or the attributes of IMPs, the fact that they're so strong and they're capable of spanning quite a bit longer than traditional type systems. And we also, just briefly touched on the fact that now you can use them in sloped or low slope roofing applications as well. So, I think again, remembering that IMPs are a really great solution for new construction projects, but don't forget about retrofits in all the buildings that are out there today that are now starting to, retrofit roof and wall systems. IMPs are a really, really great option. You saw how simple that retrofit video was, and you think about, IMPs in terms of minimizing the number of parts and pieces that are required on job sites. Roofing, when you get on the roof, things get very complicated and they get very crowded, and simplifying the installation of a retrofit utilizing IMP is real when you think about the lack of materials that you have to take to the roof. And then we talked a lot about the thermal aspects of IMPs, and that's kind of the simple one to remember, right? Because it's insulated, you're improving the thermal. There's just so much more to IMPs than just thermal. So definitely want to remember, all those things we talked about today. And when you think about IMPs in terms of sustainability, don't forget that sustainability goes far beyond product itself. And when you look at the MCA and the IMP Alliance members, all of us, collectively are doing things as organizations as well to add to the sustainability of the product and used in these applications, whether that's projects to reduce carbon footprint, or installing sustainable systems in-house at our production facilities. These are very, very important projects that are underway in many of our facilities. So yeah, I think in summary, IMPs, just remember simplicity, efficiency, and sustainability. I think those are three great things to take away from the presentation. So any further questions that I can take on here before we go ahead and close out? Doesn't look like we have any more in chat. Again, thanks so much for having us to the MCA, and thanks everyone on the call for joining us. I've had a great time talking with you for the past 60 minutes. And again, any questions that I can answer personally, feel free to reach out to myself or Brian. We'd be more than happy to have a conversation via email or phone.
Thanks, everybody.
Thanks so much.
Thank you.